Alrighty then, time for a rather short lesson about determinants and area. So here, if you have three vertices of a triangle and you're trying to get the area of that triangle, you can use this handy little formula here. You can get the area of a triangle if you take these vertices, put them into a matrix like this. Notice this row is the first point, first vertex with an extra 1 there on the end. The next one's the next vertex, and the third row has the third vertex. All of them with an extra 1 at the end. Extra 1 at the end helps to make it like be a square matrix. And if you get the determinant of this matrix you just made, and then you get the 1/2, then you cut it in half. That's the area of the triangle made up by those three vertices. So if you plug that in a calculator and you use the determinants on the matrix menu there, you get 52. And 1/2 of 52 is 26. And so the area would be 26 square units. Okay. Sometimes it gives you a picture of the triangle. That's pretty easy to remedy. You just get the vertices, the coordinates of each vertice. Again, you make your matrix here by writing out your coordinates and adding 1 there on the end. You'll have a column of 1s here. So we got 7, 2, 8, -7. And if you get the determinant of that, it is -146. Area can't be negative, and so yeah, you switch that to be positive and it fixes it. And you cut that in half. 146 divided by 2 will give you 73. So it is 73 square units. Okay, so on the back, it's a little bit different. You have a parallelogram. Those have 4 vertices, 4 corners on them. And there's a slightly different way to get the area. Really similar. You're going to turn things into a matrix, and you'll get the determinant, but you won't have to cut it in half. And getting the matrix in the first place is a little bit different. You need to get 2 adjacent vectors of your parallelogram. So your parallelogram is a shape like this. Basically, you need to get a vector as it's starting at one corner and going off to two other vertices. And so that's what I'm doing here. So this, I'm having B be the center here, and then going over to A, and then over to C would give me the vectors. So from B to A makes it go left 5 and, well, up and down 0. So that's my first vector. And from B to C, I have to go down 2 in the x component. And it has to go up 4 in the y component. And that gives you 2 lovely vectors here. You then put them in your matrix here. And this time, you're not going to make a column of 1s. You're just going to put these 2 in the matrix here, and then you'll get the determinant of that matrix. And what you get that will be the area of the parallelogram. So plug that in, and you'll get your answer. You'll get -20. But area really can't ever be negative, and so much like last one, you have to do absolute value, which makes it positive. And so this is going to be 20 square units for this parallelogram. And this can also happen if you have a picture, so pick some starting point. You need to get the vectors that spawn from it to 2 neighboring vertices. This vector up here was 6, 4. This one down here was 11, -4. You put them in a matrix like so. You get the determinant of that matrix. Make sure it's positive, and you'll come out to be positive 68. And so yeah, if you follow along, that'll be 4 of the problems. You just get some determinants, and you get the areas using that.